Welcome back to the third and last part of this tutorial. We are going to see now a few other band combination, and finally we are going to style our floating map. At this point, let's group these four layers and call them WaterInWetland. Fine. Let's see if the other combination that we have previously created also works fine. So on the same configuration folder, we go under layer and we choose the other configuration. Try with WaterBodiesMapping. Take, for example, on the 7th of December 2017, and let's hope that this works. We have a black spot. For some reason, this configuration doesn't work. Try another year. If it is just this one, again, black, it seems that the WaterBodiesMapping band combination doesn't work. Let's try with SimpleWaterBodiesMapping combination. Again, December 2017. Wait until the status bar finish to run. This might take some time. It seems that also this combination doesn't work at all. And here we have an error message. What is the reason? No idea. Okay, never mind. With this I wanted to show that not all the combination works fine. It may be that I didn't put some parameter proper, but at least we know that WaterInWetland works properly, and this really helps you to identify float in the past. But let's see what other combination are used for. Go back to the simple templates and check the most important combination. We have bathymetric combination. Take again the date 2017 on the 7th of December. We have bathymetric selected and we click on create. You have that. Bathymetric combination is actually a combination that gives you a range of blue for waters, and this range of blue will show the depth of the water at different parts of the ocean. So in that case, we don't have really deep water, so we cannot really use the bathymetric combination. But let's check the Geology Band Combination. To interpret this image, if there is a lot of vegetation, like forest or grass, the image might show up as bright green. If there is bare soil or rocks, they might look reddish or brown. And if there is water, like lake or river, it could appear blue. In this case, it's not really clear, but in other cases, it can be useful, this combination. The moisture index. Here we have the moisture index. The moisture index helps you to understand droughts or floods. This is for us important, and also how plants are actually doing. At the other end, if we have a lot of moisture, it can also be that the area is wet, and therefore it can be that the area is flooded. Swamp, marsh, flooding are dark blue or purple, and dry places like desert or sand appears bright yellow or orange. It's interesting to see between the flooding analysis and the moisture index that you have obviously some wet area here, and here apparently this soil was not compacted, it was still full of water but not flooded. So you can see, playing around with different band combination, you can gain a lot of information of your site. Take again the WaterInWetland of the 7th December 2017, and let's build a nice looking floating map. Unfortunately, for this type of work, I need to use another GIS software, Global Mapper, because as far as I know, QuantumGIS doesn't have this tool. So, but before going to Global Mapper, I need to download the flooding extent. Download as a TIFF is fine. Resolution I keep 10%. The bounding boxes I keep the current window, and I click on download. Check if the download is successful. Here I have my downloaded area. It is a rather small file with a bad resolution. At this point I open Global Mapper. Here I have Global Mapper. I open the downloaded images, and the image should be automatically georeferenced. In order to be sure that the image is georeferenced, I download a Google Earth image or a Wall Street map, it doesn't matter. Okay, I see that the image is properly georeferenced. Fine. Now I select the Sentinel-2 image and I right click and I go under layer and select create area feature from equal value. I choose Sentinel. Okay, and here I choose now the color which I pick from the map. This blue. Okay. You see that the software vectorized the blue area, and this is exactly what I want to export again in QuantumGIS. I just visualize this layer and I'll go to File, Export, and export vector LiDAR format as a shape file, and I save it. For example, I call it float area. This is all what I have to do with Global Mapper. I can close Global Mapper. Now I import this layer vector, its float area, and add, and here it is. You see the float area is actually not nice looking. That's why I want to improve the quality and the style of this area. I can take out Sentinel Hub plugin because I don't need it anymore. Now I go on Processing Tool under Toolbox and I activate the Processing Toolbox window. Here I type smooth and I will find a command for vector that smooths vectors layer. I want smooth the floating area, iteration 1, the rest I leave it like it is and I click Run. It looks a little bit better. I can smooth it once more. Same process, smooth. From the smoothed temporary file, I run it again and I close. Now I have a nice smoothed shape file. Compared to the original one, it makes a big difference. Now it just matters to style this smoothed file. As you see, this is a temporary file that we need to make permanent, so right click on it and make it permanent and call it floating area, or like you prefer. Now this file became permanent. We style it a little bit. We do it simple blue, kind of transparent, without stroke. Okay, now we have a nice floating perimeter. But before creating our layout, our nice looking map, we have to go on the field and cross-check if our map corresponds to the reality. This you can do asking the host community, asking the refugees, the displaced people, looking for signs that prove the existence of water, for example, sign on rocks, on trees, and also checking the type of soil deposit, sand, silt, or even checking change in the vegetation. That's the end of the third and last tutorial. Thank you very much and see you soon.